Hello everyone, this is for section 9.2 for pre-calc. It's on arithmetic sequences. And an arithmetic sequence is a sequence of numbers that has a common difference, like 2, 5, 8, 11, 14, and so on. When there's a common difference, it's arithmetic. Now, it doesn't mean it has to grow. It could shrink. These would have the same common difference, but this one's shrinking. Okay, so the difference, if the difference is positive, it's growing. The difference is negative, it's shrinking. Okay? The pattern to find the formula or the expression, sometimes you want just the expression, but the formula for an arithmetic sequence is this pattern, where D is the common difference, and C, I don't want to call it your initial point, but this is how you find C. 1 second. Yes? All right, you guys, I'm back. So let's say I want to find the patterns, the formulas for these two right here. The common difference, I hope you're seeing, is 3. So the difference is 3. So I know this much of it, so A sub n is equal to 3n plus c. Now I have to find the value of c, because that's what's missing. It's the first term, so 2 minus the common difference, which is 3, so negative 1. So A sub n is equal to 3n minus 1. This would be the formula for this pattern right here. So A sub n would be equal to 3n minus 1. If I wanted to do this one, the common difference is negative 3. So you have A sub n is equal to negative 3n plus c. And then you go A sub n is equal to, I got to find c. C is your first term minus your common difference. So it's 5. So c is 5. So negative 3n plus 5. Okay? There you go. Now, that's just the start. That's just how to use this pattern. That's an arithmetic sequence and how to come up with the formulas for it. Now, what you're looking to also do is to add up a sequence of numbers using some formulas for it. Okay, so here is, let's see, I go back to this one, 2, 5, 8, 11, and so on. Let's say I wanted to add up the first 20 numbers in this pattern. Well, this is a formula that will do it for you. And let me explain how it comes up. So again, what you're doing is you're finding the sum of the first so many terms in the sequence. You don't have to find the first 20 numbers and then go through and manually add them. This pattern will do it for you. And let me explain how it comes up. Okay, this dude, Carl Friedrich Gauss, I think he was in the 1700s, but when he was, it really doesn't matter. He was a famous mathematician, and this is one of the things that legend has it that he came up with. It was in elementary school, and he was very precocious and quite the intelligent individual. And the little one-room schoolhouse he was sitting in, the instructor was getting annoyed by all of his questions and said, "Hey, go sit in the corner and add up all the numbers from 1 to 100, all the way up to 100." Okay? And legend has it that, not in the blink of an eye, but close to it, turns around and tells the answer. Bam, here's the answer. And of course, then the teacher was really embarrassed and like, there's no way, you just made this up, and kicked him out of class. So this is what he did. This is how he envisioned it. So if you have 1 plus 2 plus 3 plus the numbers in between, then 98 plus 99 plus 100. This is what he's seen in his head. He took that sequence and turned it around. 100 plus 99 plus 98 plus 3 plus 2 plus 1. And then what he did is he added vertically. So he had 101 plus 101 plus 101 plus 101 plus 101 plus 101. And if you look at that sequence, how many 101s are there? There's 100 of them. Repeated addition is the same as multiplication, so that's 101 times 100. But isn't this twice too much? Because I didn't want the sum of all of this. I only wanted the sum of half of it. So you have to divide by 2. So in other words, it's 50 times 101. Now let me explain this pattern. I want the sum of the first 100 terms. You're not filling that number in. Well, you're filling it in, but okay, let me show you where. So you got 100 over 2, and then you have your first term, which is 1. That's the first term, plus the last term, which is 100. So you have 50 times 101. There it is. Okay? This will find the first, it's called a partial sum of an arithmetic sequence. So I'll give you some more practice with it. Here goes. I want the first, add up the first 150 terms generated by this pattern. So just getting used to the verbiage. I want the 150th partial sum using Gauss's method. All right, so here goes. F sub n is equal to n over 2, your first plus your last. So in this one, I want the sum of the first 150 terms. So I fill in 150 there, over 2, your first term plus the last term, 150th term. Okay, what is a sub 1? I take 1 and fill it into this pattern. A sub 1, you're taking 1 and you fill it in, 2 times 1 plus 3, so a sub 1 is equal to 5. A sub 150 is equal to 2 times 150 plus 3. So a sub 150 is equal to 150, and I wrote 105. I think my dyslexia is showing here. What's the deal? 150th term. So that's 300 plus 3, so 303. Now I just fill in what those two numbers are. So that's 75 times, because that's 75, 5 plus 303. So it's 75 times 308. Whatever that is, that would be the sum of the first 150 terms generated by that sequence. Okay. Given this sequence, find the 150th partial sum. So add up the first 150 numbers that are generated by that pattern. So filling it out, you want S sub 150, the first 150 terms in the sum. So that's 150 over 2. You need your first term plus your 150th term. So again, you need to find your first term and the 150th term. Well, to get the first term, oh, okay, we got the first term. Okay, that's 5. But to get the 150th term in the sequence, you're not going to just do these numbers all the way out until you get to the 150th one. That would be crazy. You need to find the formula for it that generates this pattern so you can find the 150th term in the pattern. All right, so backing up to what I did in the first page, I need to find the common difference. So it looks like you're adding 11 every time. So D is 11, so A sub n is equal to your common difference plus C, where C is your first minus your common difference. So 5 minus 11 is negative 6. So A sub n is equal to 11 times n, just following the pattern strictly, plus your common difference. Okay. So I want A sub 150. I need my last term. So it's 11 times 150 minus 6. All right, so let's see. I did that ahead of time. So let me make sure. So you can grab the calculator, look at the notes, do it out. So that's going to give you, it looks like 1,644. 1,644. So that's this term. So S sub 150 is equal to 75, your first term plus your last term. Okay, so that equals 75 times 1649, whatever that's worth. So it looks like, yeah, I didn't multiply it out, but there we go. You guys can do that. Being lazy, all right? Ooh, S sub 150, 1644. Okay, if you're really interested, so in case you're playing along at home and you want the number. So let's go. Where did I write it? 75 times 1649. So it would be 123,675. That would be the sum of the first 150 terms generated by that sequence. So again, what you did is you kind of set up this pattern. That's the summation for the first 150 terms. I had to find the first term and the last term. The first term was given to you. I had to find the 150th term. So I had to come up with the formula to generate the last term. Then I filled in 150 and got it. And then I just plunked in the first and the last term right here and simplified it and multiplied it out. All right. This says, give me the sum of the first 50 terms. So I want S sub 50 is equal to 50 over 2. I want the first term plus the 50th term. So S sub 50 is equal to 25 times the first term, they tell you that, 5, plus the last term. So again, I need to come up with this pattern. So that would be D times N plus C. So A sub N is equal to, common difference is 2, plus C. C is your first term minus your common difference. So 5 minus 2 is 3. So I have 2n plus 3. That's A sub n. I need to get the 50th term in the sequence. So A sub 50 would be 2 times 50 plus 3. So A sub 50 is 103. So I put in 103. So it's 25 times 108. And 25 times 108, 25 times 108 is going to be 2,700. Okay, 2,700 would be S sub 50. Okay, for some reason I feel like that's wrong. Nope, 25 times 108, 2,750. Okay? So, given this pattern, you guys know how to type it in your calculator. I get that. But you're supposed to use Gauss's method. So I need S sub. Now we need to worry about what this number is down here. So I'm just going to change this up just to help you guys see it. If I want the sum of the first 5 terms, how many terms are there? Well, I guess I kind of gave it away. If I want the sum from 1 to 5, you'd fill in a 1, then you'd fill in a 2, and get the 3rd, 4th, and 5th term. Whatever the formula is, those are the numbers you're filling in. Notice that there are 5 terms. If you're looking at this number and looking at this number, it looks like, hey, there's only going to be 4 terms because they're 4 digits apart. But that's not correct. It's 1 more than their difference. Why am I saying this? Some kids may think you can add up 49 numbers. You're not. It's 1 more than the difference. That's why I'm taking it down to such smaller numbers, is so you can see. Sure, their difference is 4, but there are 1 more things than the difference. There's 1 more than the difference. So you can add up the first 50 terms generated by this pattern. So you have 50 over 2, your first plus your 50th term. I'm not filling 50 into this pattern. I want the last term. This is your first term. This is your last term. Your last term is going to be generated by filling in 100. Your first term is going to be generated by filling in 51. So S sub 50 is 25. Fill in 7 times filling in a 51 plus 7 times filling in the 100. Because where you start, where you're at. This will generate the first term. That will generate the last term. So I have 25. Let's see. Do I have this one here? Where is it? I'm tried to do it ahead of time, so I wasn't. Where's that one? There it is. Okay. Sorry, I lost it on the sheet. 7 times 51 is 357 plus 700. So you have 25 times 1,057, which is going to give you S sub 50 is equal to 26,425. Okay? Yeah, you guys could type this in your calculator using either of the 2 methods from the previous section, but I'm looking for you to do it using Gauss's method. because I want you to understand the first term, the last term, things like that. So it's using this pattern to do it. All right? You can verify your work by typing that in, but this is the process that I'm looking for you to go through. All right, and that's it for section 9.2.